This is the refactoring of retirement advisor directory. We named it technical debt lessons learned put into action. It's been basically been me and Thomas, even if Thomas hasn't been working on some of the parts of this presentation, but he's been reviewing most of it, so he's fine with it, so we'll carry on. This presentation will be actually in two parts. One part is very short and it's basically about the decoupling we had to do in the beginning. We're talking about the merge. That's how we used to call it, and we will talk about it just because that's where everything started, and that's how and why we decided to push this a little bit further, and hopefully that allows us to give you the background and the context you need to get the second part, which is about the replacement of Elasticsearch and with Algolia and the removal of the shared database connection. So the first part is just about the decoupling. And I'll start with a simple problem statement, just a very common strip. Carl quit is the only one who knows how to program the legacy system. And of course, someone comes to you and says, well, it can be that hard, go figure it out. Of course, this is not our company, to be fair. No one came to me and told me anything like that ever. But, you know, this is how it works usually. And then you end up with a bunch of weird things that you don't really know how do they work. And let's make a very common example. You have an application, which we'll call name application 1, and then you have a second application, which is application 2. They have different sizes. I'll tell you in a second why. And then in the middle, you have something called shared kernel. Just give the right names now. Let's give them the right names. And we have RAD to the left, consumer to the right. And in the middle, we have something that was used to be there, which is core. Now, as you can see, probably you guessed it already, we have the lines of code for each of them, and the proportions are basically kind of correct based on the lines of code of each application. And I'll try to show you basically how does it look like if you try to overlap RAD and core. If you can see, there's some kind of overlapping there. And surprisingly, RAD is using a lot of core, and surprisingly enough, maybe too much of it. But let's look at consumer. What does consumer use? If you can spot the difference, consumer can use a little bit more than core, but still basically nothing. Which kind of, if you look at it from here, is like, well, this is not the core, really. This was basically me and Thomas when we spent two weeks trying to figure out what was going on here. And it doesn't really look like this is a core. And the reason why it's not is because 95% is basically used by RAD and 10% is used by consumer, which makes only 5% of it the shared bit. And it's just that small, narrow band there. Now, it could be fine, it's not a big deal. Maybe it does work the way it is, but we have a problem. Even if we have identified somehow the amount of shared code, we still don't know exactly what is shared. And the problem is when I need to touch either RAD or consumer, that means change them, maintain them, I don't really know what I'm touching. And that means I can break one of them easily. And that's not the only thing. You have to actually deploy both just because you don't really know who's changing and what. Of course, if you're working on a feature, it's been weeks, you probably figure it out. But that's what we want to avoid, right? We want to avoid the next developer coming in and sitting down and just trying to understand what is this core about, because it doesn't really look like a core, because a core is meant to be something that's deeply inside needed by both applications, or a pool of applications, but this is not the case. This is definitely not the case. Solutions, of course, you have solutions. The first one is the one I think someone has tried to explore in the past, which is the merge of all the repositories in one big repository, and that's what you can call a monolithic application. Then you have another option, which me and Thomas came up with, which is the merge of 95% of core into RAD and 5% of core into consumer. Now, before I go any further, I think I haven't explained it properly what is RAD and what is consumer. I hope you guess it by the name of them, but that might not be the case, so just give me a second. RAD is basically the admin part / backend of the retirement advisor directory, which contains also a section called self sort of sign up and / self-service section, something like this, which is basically used by advisors who actually sign up into the directory. But the consumer instead is basically just the front end for end users. So that's just for you to let you know. There is a third option, which is just make it worse and live the dream. I think it's a good option, and probably it's one of the most common one. Let's go one by one. What about the first one? Monolithic application looks cool. Does it? Well, it's easy to maintain and deploy. Of course, everything is in one place. It's very old school. I would say it's a bit of a comfort zone as well, because you just know exactly where to look for, but you don't know exactly what you're looking for sometimes, or what is actually the surrounding. But we can still see it as a pros. And then the cons. What was the problem with a monolithic application? Everything is in one giant repository, and as we can see from the lines of code we could see before, it's 50,000 lines of code, which is not excessively bad. I mean, I've been working with code bases of even more than 100,000 lines of code and even more. But that's fine, but it's the common pattern when you have this big monolithic application, someone tries to split it. And because you have coupling between domains, and usually, but sorry, it's not always the case, poor separation of concerns. Of course, there can be more. These are the ones we identified, me and Thomas. What about the second solution? Merge 95% of core into RAD and 5% of core into consumer. What is good about it? Well, you can separate concerns better, or I would say you have another chance to separate them. And the shared bits, let's say they are highlighted in a way, because you have first less code, you can easily see what is really needed. You don't have things that, well, is this really needed? Who's using it? I don't think this is used by this application. What the hell? You don't have this moment. You have, of course, a smaller code base. You don't have anything in the middle. And you actually have a good opportunity to refactor the whole legacy software, which is in this case 3 applications. 2 applications actually, plus 1 core. I'm not sure still how we can define it, sort of library / engine, something like that. What's bad about it? It's time consuming, no doubt it's time consuming. And you still have 2 applications to deploy, no doubt. And especially when you're basically changing the shared bits, that's when you should be deploying both. And last but not least, you have shared code that will be duplicated. Now, don't get too scared about this last statement, because that's not actually true. Because I'll make an example later, but basically when we duplicated things, we basically made sure we were just taking the things we needed from the files that were duplicated. But we'll get back there in a second. First solution, make it worse, live the dream. It's awesome. You can blame the previous developer. You can spend all the time you want ranting about it in the next retro. You can get paid, have a happy life. What's bad about it? Well, you're not any better than anyone else. No, not the previous developer, definitely not. You're not going anywhere in your career, and you can actually sleep at night. I can probably, but maybe sometimes I cannot. So our winner was the second option, which is the merge of the 95% of core into RAD and 5% of core into consumer. And here's why. We have to be very honest about it. It was mostly gut feeling, but because we were basically deep diving into the code bases, free code bases for 2 weeks, probably even more now, if I think about it now. And we just couldn't understand why there was this shared database models. We will get back to that in the next part. It's basically allowing, for instance, the read-write access to both consumer without any reason, while consumer by definition is just reading things, should not be writing anything in there, not even by accident. And to us, this was just a major marker of a design issue. Then, yeah, this is probably the weakest reason, but we don't really like monolithic architectures, or we just think it's kind of old way of doing things, which can work, might not work. I don't think, and Thomas agrees with me, it's not just the right reason to scatter code around repositories just for the sake of making things smaller and having things more maintainable. It can work, but we actually see it didn't work. And again, the reason why we started all this work is because we were asked to do it because developers were struggling with these free repositories. So this was the execution. Me and Thomas spending, I would say, a few weeks actually doing this. What happened was we had 2 PR, they both got merged. This was actually January, and I think it took 5 to 7 weeks, probably, if you forget about the Christmas period. Everything went smooth and fine. And I just want to highlight actually the number of the lines of code we moved. And if you make the math, you will see more or less that the proportions are the ones we were trying to highlight earlier. Slightly different because of the tests, but we'll talk about that again soon, so bear with me. Is that over? We actually thought that was not over, it was just the beginning, and we had these questions in our mind. Is it okay to keep duplicated code? Again, not really duplicated, but you will see. Is it required, really? And what about the shared database access? Is this something we need? It doesn't smell right. What about Elasticsearch? Can we just use Elasticsearch to feed consumer with data? Why do we need to use a database? It doesn't look right. And this other thing is kind of weird to understand, but believe me, Elasticsearch, the version we have in production, is quite ancient, and it might sound easy just to go and upgrade it. Well, it was not, but it was one of the questions. Is it worth trying to upgrade it or switching it to a managed indexing service such as Algolia? And finally, did the next developer's life improve? To be fair, we don't think it did, but we had a chance to work on it again, and that's why we have the second part, which is about the refactoring. So we have the problem statement again. It's quite similar to the previous one. Someone comes to you and says, well, did you finish your software yet? Well, no, I'm still paying off the technical debt from the last programmer you brushed. Well, I don't know what that means. That explains a lot, dude. So, of course, again, this is not my advice service or maps now, but you know, it's a typical problem. Someone rushed the new for any reason, or you felt the rush, you create a huge amount of technical debt. Now it's, you know, your problem somehow to deal with it. Let's talk about the architecture, because I started talking about RAD consumer. Let's look at it. So we have RAD on the left, consumer on the right. We have a database that RAD uses on the bottom left for read and write access, tons of models, things legit, of course. And then we have an Elasticsearch instance that we manage in-house, actually in-house/in-house, it's Heroku, which of course does get something written by RAD and just, you know, gets read by, this stuff gets read by consumer. And I want you to focus on, I think you might have spotted it, but there's a fourth arrow somewhere there in between the database and consumer, which is somehow asking, I mean, the consumer is basically asking both the database and Elasticsearch to do stuff. And well, for us, that's a little bit of a red flag. And as you will see, it's basically mostly shared database models and some session management, actually in write access, but I didn't want to add another arrow just for that. So this didn't look right to us. This didn't really look right to us. Ideally, what we try to achieve is to basically get rid of this arrow and just have everything flow. If you look at it now, it looks like it flows a bit, right? It flows from one side to the other. And we have a database for consumers, tiny database for the session. Now, small, very quickly about the session for consumer. There's not really a need to have this database for a session, but that's what they were doing. That's what they're doing now, because the session is quite big in consumer, and that's because we're basically storing a lot of historical information, like previous search and previously visited firms, which might sound nothing, but it's actually a lot of stuff. And cookies are just not enough for that, so you need to store them somewhere else. Of course, you can use Redis or, you know, Memcached, whatever. But we had a database. We just thought it was good to just use that and not reuse the existing database. So this is our ideal world, which is just basically no shared database connection and reliance on Elasticsearch for consumer only on Elasticsearch. But why is it there, the shared database connection? And there are two reasons. One is that we need to fetch some small seeded tables from RAD, and namely investment sizes, qualifications, accreditations, and there are a bunch more. I think it's 5 or 7 total. These are tiny small tables, literally like static data seeded once and someone forgot about them. Yet somehow consumer keeps on fetching them all the time, even if that's not the case all the time, and you will see that in a second. And the second is to retrieve coordinates in order to display the closest advisor in the firm profile page. So for those two reasons, can we remove it? Yes, we can. The first one, can we remove the seeded database? The seeded tables? Can we just find a different way of reading them? Yes, we can. We can just copy the content of these seeded tables into a translation file instead of reading it constantly from a database, which is, by the way, something that we just found done in some places in consumer already. So we didn't even have to think about it. We just couldn't understand why in some places they're doing this and then they're just fetching from a database. And our guess is just they were just doing this in different moments in time and different people, just you have a shared thing in between two applications. You have models, rich models, you just use them. But yeah, you can just copy these static things. And if you change them, you just change the translation file accordingly. There might be other solutions, but this is one that was already there. Why not keeping on using it? The second one for the coordinates, well, you can actually do that without using the database. Come on, you can rely on Elasticsearch by just doing an additional query. That's what Elasticsearch probably shines at. Like, it's just you can run a geolocation query quite quickly, and that's actually the reason why we actually think Elasticsearch was chosen in the first instance years ago, because they need the geolocation feature, which you will see again in a second. It's massively used. So these are the solutions. What about the second problem, the reliance on Elasticsearch only for consumer? Why would you do that? Well, why is the consumer doing that? In essence, consumer is a search engine. Let's be honest. Should be able to handle complex queries, simple queries doesn't matter. But that's exactly one of the use cases for an index like Elasticsearch. You have an index, you want to build it, you use Elasticsearch or whatever is the alternative available. And the second reason is, well, consumer doesn't need any other non-static data apart from the content of the index itself, like literally 3 entities, advisors, firms, and offices. That's all you need for consumers to work in read access only. Can you do that? We are already doing that in a way, because we're already querying Elasticsearch for the searches, but not for everything, as we found out. Like for some searches, like they were like querying the database to retrieve the coordinates of advisors, this so crazy nested way of doing this query was like, for us, defeating also the purpose, actually. So you can remove that, just again rely on Elasticsearch. And again, yes, this is how ideally looks like. We looked at this already. But we have a problem. We have a problem because this version is quite old, as I mentioned already. And so, yeah, we try to think about just upgrading it. That would have been this very easy problem. I mean, if you think about it, it could be very easy in theory, but actually Thomas worked on it years ago and it got stuck tremendously. He said he actually also asked for support on the Elasticsearch forums and this kind of stuff, and he didn't really get help, and it was just difficult. No one used to develop applications, and then they migrated back then from an old version of Elasticsearch. But the problem was the geolocation feature, because it's very crucial for consumer, and it drastically changed the API somehow in the new versions of Elasticsearch. So we needed to put a lot of efforts to fix that. To be fair, Thomas agreed with me. He actually tried that. We didn't want to do that. And yeah, one doesn't simply change Elasticsearch version as one might think. Do we have alternatives? Yes, we do. We have Algolia. We use it already, and we can just move everything into the cloud. But let's look at all of the advantages. It's in the cloud. Sure, it's managed. It's fairly easy to use. We use it already. It's must for the main website search, and it's a good cost-effective solution. It's not more expensive than our Elasticsearch Bonsai instance in Heroku, which is in the range of a few hundred something pounds. But that's not the point. It's really just it's a good cost-effective solution in general, especially based on our experience from Mass, the main website. There are disadvantages, to be fair. We didn't mention them, not because we don't want to mention them, but because you will see them. We had to hit the wall. So, but ideally, this looked great. Like you just have this Algolia thing in between them. It looks cool, and of course, no shared database connection. Everything looks fine and awesome. Sorry, this is a duplicated slide. But before we go any further, just to recall this for a second, we said that 5% of code was duplicated into consumer, and that most of it was shared database models. What about the rest? What was the remaining 5%? Because if you remember this, there was this narrow of 5% shared, but somehow consumer is also using a little bit of core, which is literally just for consumer. It was not for RAD. Well, nearly all the rest is test factories, and this was broadcast actually. In the process of merging core, we slimmed the factories down for consumer, but we couldn't remove all of them because all the feature specs were actually relying on them, and I'll explain it. So we had these test factories, and of course we've been talking about code, production code somehow mostly, and that's something you see quite obviously because you have features, you try to break them down, and you see what is dependent on what. But factories, well, you just run tests, and you don't, you hopefully have a good setup. And in this case, we had basically factories that were relying on these shared database models, both in consumer and RAD. And consumer had a lot of feature specs, which are basically, it's gold for us because it's basically telling us what is this application about. And it was a good way for us to look at the features, but it was very painful to basically slim them down. We managed to remove the things we didn't need, but we left them there because some things were just needed. So the rest is just test factors. I think it was important to just to clarify that this was the remaining bit. And as a consequence, actually, we had to rewrite the features because I didn't mention it here, but these features were written by using our spec, and it was also quite hard for us. We're kind of used at Cucumber, with using Cucumber here at Masso. We felt like we need to rewrite these features, and it's a good exercise for us to basically understand about the features and to actually remove the shared database connection, because if we do that, then we don't need the shared database connection anymore for the tests, at least. Then the code is something we will have to deal with that later on. So that was the general plan: discover the features in consumer, write acceptance tests for each, even if they were unimplemented, then implement the code, of course, test and deploy finally, of course. Quickly on the consumer features, some of you might know, some of you might not. Consumer does two things. One of them is basically allows the user to perform searches. And the second one is just to basically display profile pages of firms. The searches are quite different. There are three of them. One is the in-person search, phone or online search, firm by names, actually the names they use in production, and they have something special on them. Like each of them is quite different. Some of them are similar, but still different. The in-person search needs the geolocation, the phone or online needs the geolocation, the firm by name needs the randomization, which is another thing, and then the show firm profile needs the geolocation, but only sometimes, and you will see that. Plus pagination and filters, which of course, yeah, nothing important, but yeah, too important. Well, it looks good to me, to be fair. Okay, we know what's consumer about. Can we now make it work? Let's do it. But hang on, we just saw that there are a few things there, and when you try to move into the Algolia world, you find these deadly combinations. I would say, the first one is when you basically try to have geolocation with pagination, and the second one is when you try to have randomization with pagination. that's quite a problem, and I will show you in a second why. Sorry, it was too quick. Why? Because for the geolocation plus pagination, you basically need to geolocate advisors based on two parameters. One is the postcode, which is the easiest one. The second one is the travel distance. Now, we haven't spent time really explaining this problem, sorry, but somehow you cannot do this in Algolia. You cannot just have something quite complex in a way that you have 2 points somewhere in space, and you try to find the intersection, and then you try to see if the intersection, the points inside the intersections are within a radius. This is too much for Algolia. It doesn't want to do that. And the second reason, the second deadly combination was basically, it was deadly because Algolia doesn't support randomization out of the box. You cannot just have randomized results. You cannot just say, okay, this is the seed, just give me these results. And we were a bit like this, to be fair, like, why not? This is something that would just make our life easier. But we had to look for workarounds, and in the end, they didn't look too bad. This is quite complex in a way, so I wouldn't expect you to get it straight away. But I will just try to explain them quickly anyway. The first workaround for the geolocation pagination, you have to browse the advisor's index completely, basically, for records who are matching the criteria. And by criteria, I mean basically, properties, basically, search filters, or selection boxes, check boxes, these kind of things. And actually within a maximum radius from the given postcode, because we have geolocation. Then you need to collect and somehow filter out on the client side all the advisor IDs whose travel distance doesn't exceed the actual distance from the postcode. This might sound weird and complex, but it's not. It's just an additional step. And yeah, you just need to query the index again by specifying the matching advisor IDs for the current page. You say, okay, I found these IDs, and just give me these IDs. That's it. It's just an additional query, pretty much. What about the randomization plus the pagination? Again, you need to browse the advisor's index for records matching the criteria. You don't have problem with geolocation, that's fine. But then you need to randomize on the client side advisor IDs and group them per page. So you have basically some sets, like the few sets of advisor IDs that have been randomized, and each of them is basically associated to a page. So you don't have to, randomize things again. And this is actually handled pretty in a smart way, I would say. When you will check the PR, you will see, for those who will check them with the session, you will see that. And again, you just need to query the index and just get the advisors you need based on the IDs you just found. You randomized. What's the cost? Of course, and there's no such a thing as a free lunch. What's the cost? Now, you will forgive me if I use some formulas, but it's just going to be a few of them. For the first one, we only have 1 up to n plus 1 operations, and I will clarify the n in a second. For the second one, it can be 1 up to n by our rec, which I will tell you in a second what is it, plus 1 operations. Pretty much the same, where n is basically something between 1 and the number of pages from Algolia matching criteria. Pages made of 1,000 records each. So in Algolia, you can basically get pages made of 1,000 records. Of course, you can just retrieve IDs. That's why I was actually mentioning IDs earlier, because basically you can just get this huge page very quickly, and you can basically browse a whole index pretty much in a few bunch of queries. And our rec is basically required. It can be 0 if the search was previously performed, or it can be 1 if there is a new search. So yeah, that's one of the things we need to keep in mind. So what does it translate to? Well, we know actually that there are like 40,000 monthly searches on average, and if you look at the worst case scenario, you have potentially 3 pre-browse pages per search, and that's because we don't have a lot of advisors really. We have like 6,000 advisors, but if you filter them out, it's basically always nearly 1,000 or like 2,000. Worst case scenario can be 3,000. I don't think that's actually going to happen very often. And then you can actually just scroll the pages, the results pages, like 3 times, 4 times. Like, come on, seriously. If you look for something, you would probably just refine the search. You will not scroll 100 pages. So that's one of the assumptions. And if you make these assumptions, the numbers you get is basically the number you get in the end is like a 1,600,000 operations per month, which might sound a lot, but we're talking about indices, and that's how it works. If you think that things can go, you know, there could be an increase, there can be a spike, or, you know, there can be more advisors in the near future. 60K, 20% increase, well, we will end up with 2,400,000, which is less than 500,000. And believe me, this is not a huge number. We have to actually take into account that there are indexing operations as well to keep in mind. But it's tricky to predict them, as they are actually triggered by the FCA extract imports every week, and there could be manual updates. Like roughly, realistically speaking, we believe it could be anything between 20 and 2,000K, which I know is a huge range. It can be tenfold different, but it's still, if you use this numbers, it's still less than 500,000, which is not bad. What about the profile page? Very quickly. Well, it just needs to display firm details, list of advisors, and list of offices. And they can sometimes be ordered by distance, which is a feature you basically have only when you're landing on the profile page from the search. Basically, you look for an advisor within person search, you click on one of the firms you get in the search results, automatically you will get the profile page with somehow geolocated information for you know, the advisors and the offices based on the postcode you carried on from the search. And now the trickiest bit, probably, how do we structure the index? Very quickly, we have this way, which is probably the way, it is actually the way it is now in production with Elasticsearch. You just have a big nested structure. You have firm, inside you have the firm details, and then nested inside advisors and offices. But what's the problem with that? That Algolia doesn't support geolocation queries on nested entities. You cannot do that. It's just not available. And this is one of the biggest difference, actually, we found out later with Elasticsearch. And we actually need to geolocate advisors and offices. So just imagine there's a geolocation array under the firm, and there's one under each advisor and office. And that's not just doable. It doesn't work with Algolia. You cannot do that. So we really had to exclude that. So we probably need to start talking about indices, maybe more than one. What about more than one? Well, we have this potential structure we can try to investigate. But before that, my nice Zoom is telling me that we have less than a minute. So I'll carry on with this. As soon as this dies, I'll reshare it for 10 more minutes, so bear with me. So this basically is a bit different because you have 1, 2, 3 indices. You have an index for firms actually, with just the details of each firm, and then you have 1 index for advisors and 1 index for offices. This looks ideal because you have entities like you know, you keep one-to-one associations, but this wouldn't work for complex queries really, because we need to query more than 1 index at a time, and our searches are actually quite complex. And someone might say, okay, let's go with multi-index queries then. Why not? And the problem is, yeah, Algolia does support them, but then we need to kind of find this, we need to cross-reference things from 2 different, for 2 or 3 different indices for each search, and that means n+1s, like if there was no future. And to be fair, we had enough of this client-side work for the geolocation. There you go. Sorry about that. So we were here. I will just recap this quickly. So we were looking at this second alternative structure of the indices. And yeah, multi-index queries, why not? Again, you need to cross-reference things on the client side and plus ones, like if there was not tomorrow. Nope, we didn't want to do that. Is there a third option? Yes, there is. This option is basically like this. You have an advisor's index, which contains advisor details for each of them, and also the firm details for each of them. And then you have a separate office's index. So the reason why this might work actually, and I'm pretty sure some of you might have seen it already coming. Why do you have to duplicate the firm all the time? And the reason why you need to do that is because I will tell you that in a second. But before that, bear in mind we need to have the geolocation. This is the most important bit. This is why we're basically structuring the index in such a way that we can actually perform geolocation queries on them. And in this way we can do that. We don't have any issue. We can query one index at a time, only one and only one. And for the profile page, we can just query both. We don't even need multi-index queries of complex queries like that. That's pretty straightforward. So we had this moment in which we said, okay, this might work. Actually, maybe we should actually go with it. And why not? Well, we started the execution, but even before that, yeah, I just wanted to clarify that, yes, you have to duplicate the firm, but that's kind of fine in a way. That's what you need to do sometimes in specific cases. I think someone is probably not muted, Dobrin maybe, but yeah, just let you know, Dobrin. Anyway, I think we are actually running out of time, but we have literally like 5 slides left, so bear with me, 5 minutes, we'll be done. So yeah, there will be duplication, but we kind of investigated it kind of quite a lot, and it looked like it's fine. Algolia does support the solution. Actually, the previous structure of the index in Elasticsearch is exactly like this, like nearly like this. You have duplication, but it's not a big deal. So yeah, we liked it. We tried to do it. It took a long time, to be fair, and I think this time it took months. But we made it, and as you can see, we have a huge PR, and it's a lot of lines of code that have been moved. And this is the PR you guys will be reviewing, some of you, and this is one of the reasons why we are having this presentation. Now, this is probably not non-exhaustive. I mean, this presentation is not meant to, you know, answer to all of your questions that you will probably have, but hopefully it can kind of give you some guidance, and I'll be sharing everything, you know, the slides and the presentation in case someone wants to look at it. And yeah, that's pretty much it, to be fair. I think we kind of, well, next steps are quite just, you know, test it and review it, deploy it. Just to mention the test bit. We're testing it. We have been testing it for a few weeks now. Everything looks kind of good, apart from one small issue with the counters, but you don't need to worry about it for now because this PR doesn't have anything to do with that. So don't feel like you cannot review it today or tomorrow. I'll be unwhipping it for those who can review it today or tomorrow or the first thing in the morning. So that's pretty much it. I'll leave you with this, but you will read it later. And if any of you does have any outstanding question, I know we kind of ran out of time, but if anyone wants to raise any question, we can carry on for 5-10 minutes, and that's pretty much it. Again, it's not exhaustive, and we probably have, I know, a final review of this presentation, or maybe a few additional slides to, you know, to show the final outcome of all this. So I hope that was entertaining or just boring. I don't care. I don't know. I hope it just helped. So let me know any feedback or any concerns, just raise them. If there are any questions, raise them now, please. Or I'll take that as a no. So I think we can call it then. Again, thank you for your time. Thank you for bearing with me and Thomas. And we'll keep you updated. We'll keep you updated. I hope this was helpful. That's
Thanks,
it.
Giuseppe.
Cheers, guys. Thank you so much.
Thank you.
Cheers. Bye.